I have my IKEA desk taken apart, and you can see the resulting mess on the floor because the desk wasn't moving up and down. And a few years ago, I got this desk in 2017, I think. And a few years ago, I had trouble with it moving a little bit and then stopping, moving a little bit, then stopping. It turns out the power supply was to blame that time. It was faulty, and IKEA sent me a replacement in the mail. But this time, the desk for the past several months, it hasn't moved at all in response to button presses. And so I have the desk apart. I've taken out these motors that look like windshield wiper motors. And the quality of the components looks pretty good. There's no obvious blown components in here. And once I took it apart, I found that things are actually running. So I'm going to set this motor here and press a button. The desk is in reset mode, which means I've held both buttons down for 10 seconds. And it's waiting for me to put it all the way down and detect that the motors can't spin anymore. And that's how it will find the home position at the bottom. So it won't allow itself to go up right now, but it will go down. You can see the motor spinning, the other motor spinning as well. But I just noticed that, let's see if I can hold this. While I was holding the motor, it was intermittently spinning and not spinning. And I noticed that there's a little contact here that touches the body of the motor, I think, to establish ground. So if I see if I can set this down. So I noticed there's a little contact here on the side of the motor that touches the motor body. And when I press the down button and hold it down, you can see the motor spinning. But if I put pressure on this PCB away from the motor will stop. And the button's still being held down, but it seems like something in here is causing the connection to fail. So I'm going to bend that contact and see what happens. This is hard to show with one hand, but just coming in here with a flathead screwdriver and scratching the motor body where this contact touches it and making sure the metal's really unoxidized there, really scuffed up so that the motor body makes really good contact with this little tab. And when I do that and hold the down button now, if I flex the PCB, it seems like the motor will keep spinning. So with the motor body all scratched up and the contact also scratched up, now when I hold the down button and flex the PCB away from the motor, things keep running just fine. So the hint here was that the system was working when I had things out in this orientation, then it stopped working, and then I actually flipped the motors over and suddenly it started working again. And it worked until I put it back together, then it didn't work. And that kind of intermittency usually suggests a faulty connection. I tested all these wire connections with across the bus with the other side of the desk, and it seemed like everything had a good connection. So really the only thing left, if it's an intermittent connection, would be something like this kind of tab that touches the motor body. That's always something to be suspicious of when there's a metal casing that isn't plated and you need to make electrical contact with it. Usually this can get oxidized, so it's a place to look for intermittency. While I have the desk open, I thought it'd be a cool time to take a look at these components in a little more detail. So we have these two motor drive units. They're exactly the same on each side. And the motor is a Bosch, it looks like a windshield wiper or a power window motor. These are made in Germany. They run on 24 volts. This whole system is 24 volts DC. So I'm not too worried about the risk of electric shock here, but do be careful if you open it and you have it plugged in. The motor is connected via, looks like a worm gear to a spur gear, and the gearbox is indicated that it's PBT glass fiber 20%. So interesting material here. PBT is, with glass fiber, should be pretty tough. And we have this, what looks like nylon hex center drive for the lead screw that goes down the leg of the desk. So this lead screw spins and just screws the leg longer and shorter. And when you turn the desk on, you'll hear it click. You can see we have two 24 volt DC relays here on the PCB, and presumably those control the motor in each direction. I'm not exactly sure, but let's see if we can hear a difference. Oh, there's down, so let's see which one is moving. So this one is clicking, and this one is not. So this one is for the down direction. I can't move the desk up right now because, again, it's in reset mode. It won't finish resetting until I put it back together and it bottoms out, and the motor detects that it can't spin. And originally I thought this desk had some sort of limit switches, but it seems like it doesn't. There's a clue on the PCB right here. You can see there's a terminal there that says Hall 1. This likely has a Hall effect sensor to detect the rotational, like rotations of the motor. And it does seem to be counting. When you, if you move the desk disassembled, the motors will run and then slow down where the end of travel would be and then stop on their own. So it indicates to me that the system is counting how many revolutions it's making in the absence of a limit switch. And that also means that when you home the desk at the bottom position, it doesn't actually need to detect the top of travel. So it'll just stop traveling when it counts the correct number of revolutions. And counting revolutions is also super important for positioning the desk somewhere in the middle of its range of travel, because if there's basically, you need the two legs to move at the same speed. And these are DC motors, so you know, they aren't like stepper motors. They just spin at some arbitrary speed. You can't really predict that based on the input power. So you actually have to count the output revolutions to make sure that the desk moves a known amount on each side. So there's some kind of Hall effect sensor shenanigans going on to count the number of revolutions of the motor or the gearbox. Can't quite tell. The PCBs look really clean. Interesting shape. It fits in here at an angle. So I think with the motor body scratched up and these terminals making better contact, we can try putting this back together. So I'm going to unplug the power, and you'll notice inside the desk here, these connectors come in and are just shorted together. So either any connector works in any of these ports. Everything's connected as a bus. There's a signal wire. Apparently some people have done some reverse engineering on this desk and found it uses a really simple small area network protocol, like a sort of like a simple version of CAN for vehicles. And then we have positive and negative. And like I said, the power supply is this really heavy 24 volt power supply from Roll Ergo. They're the ones who contracted with IKEA to make this desk underframe. So we have output is actually listed at 35 volts, 2.12 amps, but I haven't seen the output that high. To me, it generally looks like I'm getting about 24 volts out, so I'm not sure if there's a regulator in the desk. I haven't actually tested the output of the power brick directly, but yeah, let's put it back together. So I have the power disconnected, and let's try to do it one-handed here. So I have these pieces of paper in here just to prevent the motors from shorting against the metal frame. And one cool thing about this design, the motors go in face down like this, so the relays are on the bottom, and the motor just sits in here. There's a rubber bumper on the back and some rubber bumpers on the bottom, and the back just sits inside this little cradle that'll keep it from rotating. And you just have to line up the lead screw with the motor output, and you may need to wiggle one or the other to get them to line up correctly. Like this one wants to go over here, so once you get it kind of lined up, you can put it on here and twist it, and you'll end up turning the lead screw a little, which will align the motor. So don't worry about if it doesn't line up completely right. Just kind of nestle it on there until it does, and then twist it into position. And this comes from the factory with these wires tucked on top of the motor, so you can do the same thing. It just pushes on there, and it's interesting because it doesn't need to be bolted down at all. Super convenient to take out and put back in. You don't have to take out any bolts inside this box to get the motors out. Some videos I've seen online say that you do have to take out the 3 bolts that are visible under here when you're looking at the motor, but you don't have to take those out. Okay, let's do this one. If you have 2 hands free, this is much easier. Okay, so I just rotated this lead screw a little bit counterclockwise to move the desk up a little, and then I was able to set this motor back on. So let's plug it back in and make sure it still works. Hopefully the connector was the problem with the intermittency. Okay, moment of truth. Let's see if this goes up. Actually, so it's still in reset mode, so the up button won't work because I've already held these buttons 10 seconds at the same time. So I'm going to go down, and it should immediately bottom out and stop. Okay, now it knows it's at the bottom, so now I should be able to go up. Excellent. So you'll see it stop at the top of travel on its own. Let's wait for it. You'll see it slow down too. Okay, so at the end there, you could hear the motors slow down on their own. And now it's at the top of travel, and I'll put it back down to make sure that works. So originally when I took this apart, I had I was in a bad situation because I took the motors out and suddenly it was working, and I put it back together and it was briefly working. And that's a bad situation to be in because you, obviously it wasn't working before I took it apart, and taking it apart and seeing it all working correctly, putting it together and seeing it working correctly generally means you don't know what the problem was. And so I'm glad to have found what seems to be an intermittent electrical connection. It's a plausible explanation for this not working. And having scuffed up the connection, I think it should work now. So if this happens to you, if your desk stops moving and the power supply seems good, try making sure these connectors, these tabs are making good contact with the motor casing, which can get corroded over time, and give them a good scuff. Or if you have some sandpaper, maybe sand them lightly. And yeah, when you're doing that, make sure the power's off, just for your safety, and test the desk out again. And if you get the desk in a weird configuration, you might notice when you take these motors out, the desk frame falls to its lowest position. That's totally fine. That's how they calibrate these at the factory. Just let it go all the way down to its lowest position on each side. Hold both buttons for 10 seconds to put it in reset mode. Hold the down button to let the motors discover that they're bottoming out at the bottom. And then you should be able to move it up again. Thanks for watching.